Hello, PreCalc. 24th, that is Friday, Saturday, or Sunday, and we're starting out with logs to other bases. So on the calculator, you can find an log, which is base 10. Even if it is not stated, we understand that anything written as log is base 10, and ln is base e, the natural log. So what about logs to other bases? If you have an n-spire, your calculator can take them straightforwardly, but if you don't, a TI, we're going to show you how to find logs to other bases on your calculator. So we'll develop the formula. So say we start out with log to some other base, so I'm just going to call it base b of an expression x. And in order to think about this better, I'm going to write this in exponential form. So this is log form because of the word log, and we recognize that the relationship is this base to this exponent is always this number. So I'm going to write that b raised to the y equals x. Alright, so now I want to know what y is, because that's the log to the other base. I want to know what this y is, but the y is up in the exponent, so I'm going to bring it back down with a log. So I'm going to take the log of both sides and put the log back in. Looks different than the first logarithmic expression because now there's a log on both sides, and it allows me to take the exponent, and one of the rules of logarithms allows me to take the y and do what with it? Can run down in front. So, alright, so we get y in the front now, log b equals log x. Remember, I'm trying to find y, which is equal to this. So I'm going to solve for y by dividing both sides by log b. Alright, do you see that I have improved my situation? I'm not able to put that in my calculator. That's an unknown base. I mean, it's a known base, but it's not known to the calculator. The calculator only knows base 10 and base e. So maybe it's a base 5 or a base 3. So here, this formula tells me that I can put in an log, a log, which is base 10 of x over log base 10 of, that's a b right here. Looks almost like a 6. So I'm going to write that up here. That's the result. And I'll show you how to do one. Alright, that's result. I can get rid of how I got the result, but I'm going to keep the result in front of us. Alright, so for example, and log to the base 5 of 8. So I can't get that out of my calculator as it is, but I can change it to this, which I can get out of my calculator. So this is my x, this is my b. Follow the formula. Log 8 log, so the calculator knows the log, over log b is 5 in this case. So I just tap into the calculator log 8 over log 5. I forgot to do that, so somebody do that for us, and tomorrow we can get that number. Alright, and it's going to be a number. It's saying what exponent do I give 5 to get 8? So I know 5 to the 1 is 5, and 5 to the 2 is 25. So it's going to be somewhere between 1 and 2, closer to 1. So 1 point something, when you put this in your calculator, you can get that number. And also it works if you use ln. So as a grand experiment, put in ln of 8 over ln of 5, and you'll get the same number, whatever it is, 1 point something. Alright, before I leave this topic, just a little memory aid. notice if I'm looking at log to the base 5 of 8, I can remember, see how the 8 is a little higher in the expression than the 5? And look over here, log to the 8, the higher, over log 5, the lower. So I always remember that relationship. It helps me remember how to write it in this form for the calculator. Alright, so that'll be coming up in our work. So, the other topic for tonight, that was a short one, is solving exponentials. So, title this part, Solving Exponential X. Exponential. Solving exponential equations. Alright. So we're going to have equations to solve, and our unknowns are going to be in the exponents. And we are all ready for this. The first one that I want to do is e to the minus x squared equals e to the minus 3x minus 4. Alright, so these are in the exponents. The unknown is in the exponent. So whenever the unknown is in the exponent, I'm going to use log rules. So log rules will allow me to pull those exponents, the unknowns in the exponents down where I can use them. So because this is e, I'm going to use a base e logarithm, which is ln. So I'm going to take the ln of both sides. And it's algebraically sound to take the log of both sides. So this, I'll recall, is base e logarithm. I'll write in the little e, although it is understood that ln is base e. But now, what exponent do I give e, this base e, what exponent do I give e to get e to the minus x squared? So this whole thing just becomes minus x squared. So that logarithm allowed this to come down. And over here, what exponent do I give e to get negative 3x to the 3x minus 4? Well, negative 3x minus 4. Another way you can think about it is, and I'll just let you decide which way resonates with you, is when you take the log, once you have the word log, there's a rule of logarithms that says the exponent can run down in front. So I'm going to bring it down in front. And this exponent can run down in front. So what's ln of e? What exponent do you give e to get e? 1. So this is just a 1, and this is just a 1. So we end up with the same thing. So whichever way resonates with you, you need to be able to get from step 1 to this. Now we have just the quadratic. Hopefully it's factorable, so we don't have to pull out the quadratic formula, but I see it is factorable, so I will factor it. What two numbers multiply to get negative 4 and add to give negative 3? So it's what? Negative 4 and positive 1. Alright, so then we set each of these factors equal to 0, so that the whole thing will equal 0. X minus 4 is 0, x equals 4, and x plus 1 is 0, x equals minus 1. Alright, two answers to this problem. If you put a 4 in up here, and if you put a negative 1 up there, you'll see that they both create true statements. Alright, let me continue and show you what to do in another type of exponential. equation that you will solve. We'll solve lots and lots of these so that you will be very comfortable with exponential equations. How about e to the x plus 5 equals 60? Alright, so the command is solve. I should have said that on the last one. The command is solve, so that means find out what the unknown is. X is the unknown. So, in order to solve any exponential, you have to get the variable down out of the exponent. So we'll use log rules to do that. But before you can do that, the complication that this one has is it has a term here, and I can't use log rules until this is by itself. So I'm going to move the 5 to the other side, where it subtracts from 60 and becomes a 55. Now I'm going to use, I want to get this x down where I can work with it, so I'm going to do that by taking the ln of both sides, because that allows me to use log rules. And we learned that one of the rules is after the word log, the exponent can come down in front and be a coefficient. Alright, nothing happens on this side. So what's ln of e? What exponent do you give e? The unwritten base e to get e? 1. So we have x equals ln of 55. That's just a number. So if you plug it in your calculator, you can get 4.007. 007. Alright. So that is the answer to that exponential. Case solved with the 007s. Alright. There are so many different kinds that I'm going to have to rely on your mathematical nose to just lead you in the direction that you will go. But I will show you how many more. 1, 2. I'll show you 2 more, and there's lots of more, but I think you'll get the gist of how this works so that you'll be able to work independently. Let's say 2 times 3, and the 3 has an exponent. It's 2t minus 5. Doesn't have to have x's, so this exponent has a t in it. Minus 4 equals 11. Alright, so my desire is to get the exponent, which has the variable t in it, down where I can work with it, but it's complicated by this minus 4 and this 2. So this has to be by itself before I can do that. So first add a 4. So when you add 4, you get 2 times 3 to the 2t minus 5 equals, adding a 4, I get a 15. And then to get rid of the 2, I divide by 2. So I end up with 15 halves. So I have 3 to the 2t minus 5 equals 15 halves. Alright, now how do I get the exponent down where I need it? I'm going to take the log of both sides. But this is a little different because the last problems had e's in them, but this has a 3 here. So I have to take a log to the base 3 in order to get the most out of it. So I'm going to take log to the base 3, and you always want to take the log that matches this number here. So I took log to the base 3. Log rules allows this to run down in front. 2t minus 5 is finally down where I can use it. Log to the base 3 of 3. What exponent do I give 3 to get 3? And over here, log to the base 3 of 15 halves. So log to the base 3 of 3 is just a 1. So I have 2t minus 5. And I just taught you how to find logs to other bases other than 10 and e on your calculator. So if you recall, you'll tap that in. How do you tap it in? You'll do log of 15 halves, which is what, 7.5? log of 7.5 over log of 3. So that will get you this number here. And when I did that, I didn't write down what it is, but it's some number. So I'll put log to the base 3 of 15 halves. So that's easy enough to find on our calculators. Then I'm going to add 5 and divide by 2. So that will get t isolated by itself. Moving the 5 over and dividing by 2, I get t equals this. Now that I did get the final answer for, and I got 3.4. Alright, so you can check me on that. Alright, one more. And these exponential equations. Pause the video if you need to get this down before I erased. Alright, last one for our really big show tonight, and that is, alright, this one, like I said, there's so many different ones. This one we're going to go with another strategy rather than taking the log of both sides. The reason I'm not going to take the log of both sides is because I can never get one of these terms with the exponents by itself. So I can get this one by itself, but then this exponent will appear on the other side. The unknown is still in the exponent. If I move this over and keep this by itself, I have the same problem. So my advice to you to isolate the unknown with the variable won't work for this one because the variable is in two different spots in the exponent. But I noticed this. I can think of this first expression, e to the 2x. It can be written as e to the, I want to say x. I don't know if this is going to help. I think that I can go ahead and factor this just right off. Since I can't isolate the term with the variable, I'm just going to go to try to factor it right away. And it's a little awkward thinking what times itself will give you e to the 2x. So that's why I kind of wrote it like e to the x squared. So do you see if I put e to the x here and e to the x here, that e to the x times e to the x is e to the x plus x. You add exponents in algebra when you're multiplying terms that have exponents, you add their exponents like this. X, somewhere you can see it, like x squared times x to the third is x to the 2 plus 3, or x to the 5th. So it's no different when these exponents come out to play. So x plus x gives me 2x. So once you see that, it becomes pretty easy to factor, finish it. So what two terms will I put here that multiply to give me plus 2? Well, I have a choice. I can put a plus 1 and a plus 2, or a minus 1 and a minus 2. But I see this is minus, so I'm going to pick the minus 2 and the minus 1. Now the inner term gives me a minus 2, and the outer term gives me a minus 1. They do add to give me negative 3 e to the x. So this is the factored form. So now I can set each of the factors. Anytime you have two things multiplied to give you 0, either the first one equals 0 or the second one equals 0 or both. So we have two branches. So e to the x equals 2. So again, the exponent is in the unknown. I'm going to take the unknown is in the exponent. Take the ln of both sides, and the x runs down in front, leaving an ln of e, which is just a 1. So x equals ln of 2. So ln of 2 you can put in your calculator, but I'm happy with that as the answer. Over here we get e to the x equals 1. Take the ln of both sides. And the x runs down in front. X ln of e. Ln of e is just a 1. So we get x equals ln of 1. Now I can prove on that. I can't improve without the calculator ln of 2. But I do know the ln of 1, because that is base e. So what exponent do I give e to get 1? That same old exponent, 0. So this one actually equals 0, and this one equals ln of 2. So there's 2 answers to that equation. Okay, that'll give you a taste of what is to come, and I'm sure you'll be up for the challenge. So, till we meet on Monday bright and early, goodbye.